Hello everyone, welcome to the electrical circuit simulation series. In this session, we'll study the use of OPAMP as a non-inverting amplifier. So this is the circuit diagram. We'll see each and every component. The very first component is the OPAMP, that is the operational amplifier itself. As we can see, we are connecting the input to the non-inverting end. Then we have a feedback at the inverting end, and we have this output at the voltmeter. The input, so we are using a DC input which is directly connected to the non-inverting end. Then we have the resistor R1. One of the end of the resistor is connected to the inverting end and the other is connected to the ground. Then we have the feedback resistor, so we are using a negative feedback, so the output is given back to the input through this 100 ohms resistor. Then we have the ground to complete the circuit. Then we have the voltmeter which measures the output voltage. Now regarding the calculation part, how to calculate the output. So we have this various components. As we can see, Vin is the input and we have R1 as the resistor and RF as the feedback resistor and V0 we have at this point. So this is the output we will get. So output can be calculated by using this formula, which is equal to 1 plus RF upon R1 into VIN. Now as in our case, RF is, there is a feedback resistance is 100 ohms and R1 is also 100 ohms. So we put in the values, so 100 upon 100 becomes 1 and 1 plus 1 becomes 2. So V0, whatever we are getting, we will get, it is equal to 2 times VIN. So for example, in suppose if we have the input as suppose 1 volt, then output will be around 2 volts. This is 1.996 as we can see. And if the input, suppose if the input is of 2 volt, okay, then the output is around 4 volts. So whatever output we are getting, it would be the double of the input. So now let us use the simulation, and that SimulIDE will actually simulate this particular experiment. So now we are into the SimulIDE. Let us select the components. So first we select the voltage source. This is the voltage source. Then we need the resistor, 2 resistors. So I just take one resistor here, and the second I connect here. I place it there actually. Then we need an OPAMP. So this is the OPAMP. Place it here. Then we need a ground. So this is the ground. Then we need to measure the output, so we have this voltmeter. I place it here. Now these are all the components we required. Now let us now connect the components. So first we connect the input to the non-inverting end, okay. Then connect this ground to this input resistor R1, and the other end we connect it to the inverting end. Then we connect the feedback resistor. This feedback is between the inverting terminal as well as the output. So first let us connect this output to this particular end. So this is our output, and we can connect this. Now this is connected. Now we connect this end of the voltmeter to the ground. So this completes the circuit. Now let us turn it on. So now we have turned it on, and we can also turn on the power supply. So we are starting from 0, so let us start it. So this is input. Now this circuit is turned on. Let us make this input as 1 volt. So we just move this dial. So now this is 1 volt actually around. So this is 1, and we are getting 1.996, which is almost equal to 2 volt. So input is 1, output is 2. Now if we make input as 2, we must get 4, of course. So this is okay, sorry. So this dial is okay. So it's 2.12, so it is 4.22. Okay. So this is what we are getting. Now suppose if I make it as 3, I will still get 5. Okay, because now the OPAMP has been saturated. Now what to do in this case? When input is 3, we are not getting 6. Even if you make it as 4, the output will remain as 5. So what we want to do in this case is we need to adjust something in some parameters inside the OPAMP. Now what to do is we'll just stop the simulation and we come here, okay, right click, and in properties we need for supply, we make this instead of 5 we make it as 10. Okay, so now the voltage saturation is set up to 10 volt. Okay, now let us start it. So now we are getting it 6. So because previously saturation voltage was 5, now it is 6, so it will give the voltage output up to 10 volt. So if we now make it as 4, we are getting almost 7.9, which is actually equal to 8 volt. Now the reason this particular amplifier is called as a non-inverting, because we are applying the input at the non-inverting end, and the output is in phase with the input, and the feedback is applied at the inverting end. So here what we observe is the gain was 2. Okay, gain means gain is the ratio of output upon input. So whatever output we are getting, it is twice the input. We can even change the gain of the amplifier by just changing the value of the resistor. So if this is 100, the feedback is 100 ohms. If it becomes 200 ohms, then the gain of the amplifier will become 3. So we can actually change the gain by just changing the external resistors, that is RF and R1. So that's all for this particular session. Thanks for watching.